All right. Class. Yes. Thank you. All right. Hashtag 49. Today's date. There we go. So it says graph each function using technology. Describe how transformation this to get function shown here and both graph equations. So take a look at your handy dandy calculator. I'm hoping you guys actually have it. Yeah. Yeah, go ahead. So in the calculator, so we're going to take a look at my graph right here. So we're going to start by entering the first function, f of x. So my f of x function was x squared. Open x minus 2. There we go. So that is my original function here. That's the original function. That's what I'm starting with. Now the next one we're going to look at h of x. So I'm going to hit tab. So my h of x is x squared parentheses x minus 2 close minus 5. Now, you guys should see this on your calculator. At this point right here, you should see it on your calculator. So, what did my graph do? How did I get from F to H? From the blue one to the red one? Went down. Okay, a little bit more specific. Down 5, right? Very good. So, I'm going to say that it goes down 5. Okay, that's good. Goes down 5. Now let's go back, and my original one is blue, so F1, so I'm going to change F2. Tab, arrow up. So I'm clearing this one. X minus 4, close, squared, parentheses, x minus 6. All right. So here's my next one. Okay, so now, what's this one going to do? It's moving to the right. How much? 4. I can count it on my thing. So 1, 2, 3, 4. So to say that, that means I picked a point that I know. Right, Leslie? Okay, so I picked a point that I know, and I counted to see where it ends up at. So that same point ends up over here. So I know that this one moved right 4. All right, so it says writing equations for vertical translations. So graph of function g is a vertical translation of polynomial f. So this one is f and this one is g. So they already moved. So starting off here, this is -4, 0. Now the same corresponding point is now over here. So this point right here is now going to be -4 and 4. Because it's up 4, right? Okay, so now, just by looking at that one point right there, what can I say that this whole graph did? It goes up 4, right? So let's go through and finish these out. So if this is going up 4, and I started here, so the negative 3, when x is negative 3, what is this one going to be?
1.8.
Yeah, 1.8. Negative 1.8, because we're adding 4 to this y value. All right, next one I'm dealing with is right here. Negative 0.7, which is here now, comma 0. So this is going to be negative 0.7, comma positive 4, right? Because if I look right here, it's at 4. Next one is right here. So the corresponding point would be the x value is 1.2. The y value is negative 3.3. So what's going to be my new y value? No.
Oh, 7.7.
0.7. So if you're struggling with this in the calculator, so I'm adding 4. I'm adding 4. So it's actually this plus 4. Okay, so you should come up with a positive 0.7. And then point G, which would be, I'm not part G, this one right here. This point right here is going to be 2, comma 4. Okay. So, let's take a look. So now, the table for this one, it's over here. We're going to fill it in here in a minute. Listen, please. We're going to fill this in a minute. Okay, we filled it in right here because that's what we're looking at. If f of 0 is, so right here, f of 0, so when this is 0, we get this value right there. What would I do to find g of 0? I know that g of 0 would be equal to whatever f of 0 is, right? Whatever f of 0. So I'm writing this kind of weird. So f of 0, so it's whatever the y value is, and I'm going to do what to it? Plus 4. So it's going to look like this. Because we know that the f of 0 was this, right? Say yes. So it's going to be this, so it's going to be negative 0.86 plus 4. So g of 0 will give me positive 3.14. Okay, so now this is my x value is 0, okay? That's what this means. So g of x, so the x value is 0. So when this is 0, we had a negative 0.86. That's what that means. Now for the for the g, I'm over here now. So it's whatever value I had here plus 4. So I took the value which I had, which is right about here, added 4, and it gave me this point right there, which is slightly more than 3. Angel, does that make sense now? Okay. So I already did this part right here in terms of f of x. So g of x would be equal to whatever my f of x is plus 4. So we're just adding 4 to each of the y values. That's all it means. So they like writing it weird, but it's whatever the y value is, add 4. Okay, so let's go through. And so this is a table that we filled out already, but we did it on the points. So for g of x, When x was negative 4, you could flip back and forth on your page. When x is negative 4, g of x was what?
Negative 4. 4.
It was 4, right?
Yes.
So let me show you. When x is negative 4, the y value was positive 4, right? So fill in the rest of this right here, please, from what we just did with our points. I said please.
Even the h of x and f of x one?
If you want to. If you're feeling froggy, go for that one.
Are we putting the x or the y?
Your x's are already here. So when x is negative 3, the y value was... This is negative 1.8, right? Rafa, look.
That's exactly the y.
Yeah, that's what I said.
No, you said x.
No, this is the x.
X is this, right? It was negative 1.
Yeah. And then the y value.
Also, we're just putting the y.
Yes, for those points. So when x was negative 3, the y is negative 1.8. When x is negative 0.7, the y was 0 or 4? 4. When x was 1.2, positive 0.7.
Yes.
When x was 2, y is?
Positive 4.
There you go. Now for this next one, okay, the function h can be written as terms of f. Here we go. And it says h of x is f of x minus 2.5. So then complete the table. You already done? Complete it. Do it. Do it. Did you already do it, Mr. Brown? Is it done? Okay, then do it, Mr. Brown.
It's the same as that one.
Is it? Oh, okay.
It's like the same.
Okay.
Can you add negative 4 plus 2.5?
No, 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 this is f. Which one's f? 0, right? So it's 0 minus 2.5, which gives me negative 2.5.
They're all negative, correct?
Possibly.
That's the I.
And then once you get done with that, okay, I'm going to give you guys a moment to actually finish this, but if you're already done, go ahead and start putting the dots on here.
Of all of them?
Huh?
Of all of them?
No, which graph of what?
Oh,
H.
okay.
So it's only going to be the ones that go along with the x's here and the y's here.
Right, right.
Okay, let's see. So minus 2.5, so this one's going to be negative 8.3. Next one's going to be negative 2.5. Next one is going to be a negative 5.8. Last one's negative 2.5. So let's go ahead and put our dots on here.
Are those Y's or X's? Am I supposed to draw it out as well and do a little squiggly?
Yeah, see if you can do a little squiggly.
Touch them.
Huh?
Are those Y's or X's?
Okay, X's. This is the X's going this way, right? So for this one, like 1.2, 1.2 is going to be right here. And then the Y value right here is going to go down
Oh,
5.8.
yeah, sorry, where's the X?
Okay. Yes? Yeah, go ahead. And 2.
So it's just geometry.
Yeah.
Would this class be considered advanced algebra?
Huh?
Would this class be considered advanced algebra? Isn't that what they used to call it back in the day?
It used to be back in the day. No. Alright, so we should come up with a big Wario looking symbol here. See what I did there? Like video games, Wario. Yeah, not Mario, but Wario, like the bad Mario. See what I did there? Okay. Alright, so, okay, watch this. Number 6. Okay, I don't like that question. I do not like it here or there. I do not like it anywhere. Okay, so let's take a look. A bakery has its thermostat set to 65 degrees starting at 5 a.m. The temperature in the kitchen rises to 85 degrees when the
Ovens.
when the ovens and the other kitchen equipment turn on to bake the daily breads and pastries. The ovens turned off at 10 a.m. when the baking finishes. So, what should be the ambient temperature? The temperature when nothing is heating it up
65.
should be 65, right? So, I'm going to start at 65. So, it's going to be at 65 until what time?
5 a.m.
At 5 a.m., right? So 5 a.m. is going to be right here. I'm going to put a dot right there. We start baking at 5 a.m. Okay, so at 5 a.m., it should go up to some value. What do you think it should go up to? 85 degrees, right? Okay, so let's say it goes 85. Let's say it takes,
Isn't it to 10?
let's say it takes an hour to get there.
The ovens are turned off at 10.
Okay.
We can estimate how long it takes to get to 85.
No, it's actually, it's information that's missing from this graph that I'm giving it to you. So I'm telling you it's taking an hour to get that hot. So, and it stays that hot until what time?
So 10 a.m.
So I'm going to draw a line. It's going to stay 85 until 10 a.m. There we go. And after 10 a.m., it cools down. But it cools down to what?
60.
Back to 65, which is my ambient temperature. I'm going to say it takes 2 hours to get back to that. Again, missing information from my graph. So I'm just giving it to you here. There we go. Looks like a little plateau. There we go. Huh? It's a plateau. Plateau. All right. So, there we go. So we got a graph of it. Hopefully your graph is better than mine. Mine's kind of ugly. All right, the bakery owner decides to change shop hours to start 2 hours earlier. This means that the daily baking schedule will also start and end 2 hours earlier. Sketch a graph for the new function g, what gives the temperature as a function of time. All right. What time is it going to start going up?
3. Oh, yeah, 3.
So it should stay 65 until 3 a.m. Okay. So, and after that, it should go up to what temperature? 85. It's going to go up to 85. And how long did it take us to get there last time? Take an hour. So at 4, it's going up to 85, right? Okay. How long is it going to stay at 85? Till what time? Not 10. 8. Because we're shifting everything, right? So he's starting out 2 hours earlier, and then we're closing 2 hours earlier. So all the way till 8. And, if we're starting at 10, no, because it's 2 hours earlier. There we go. And then I said it takes 2 hours for it to cool down, right?
Yeah. Wait.
What?
10.
So at 10, it's going to be back to 65. And what did I do with these graphs? I shifted everything to the left. To the left. All right. Is this super easy? If you paid any attention in geometry, you might be able to understand this. Yeah. I said,
Right, I said it.
okay, yeah. And if you had me, then you definitely did not pay attention.
What was the wording again of the? Remember those letters they all made? They made like a sentence.
I just read it in the beginning and I
Hippies and
Sucking
Oh, okay, that's trig though. All right, okay, so don't forget, like, share, and subscribe. Hit that notification button because I'm skipping the rest of this.
Wait.
Do what?
We have an homework.
4?
yeah, do number 4.
Okay, h of 10.25. Find 10.25. 10.25 is right here. It says it's equal to 80. Ooh. That means that right here it should be 80. What would the corresponding point on the graph? Okay, right here. So it says if h is, let's see, 80 right here. There's my point, which is,
You can see.
oh, I'm sorry. Thank you. All right, so this is my point, 10.25, comma, that's a huge comma, 80. So there's my point. It goes right through there. So what would that now be over here?
60.
What am I doing?
Jumping into. Oh, so 70.
So it moves to the, it goes left to. So what would change if it was be left to? It would be this spot right here now, wouldn't it?
Right.
My new spot would be there, which is going to be
8.2.
8.25, right? Comma, 80.
See, you have to do certain questions like that because of the way it's.
I know, but I thought you guys actually, if you need help with it, I don't have a problem doing more.